Hello, calculus students. We're going to be looking at slope fields today. It's kind of a fun topic. Goes along with our differential equations. I'm going to share my screen and start the presentation. The first slide we have is going to be a warm-up. So you might want to grab a piece of paper, give the warm-up a try. There we go. And so our warm-up says, determine whether the function y equals e to the negative 2x is the solution of the differential equation 3y prime plus 5y equals e to the negative 2x. And we've had some of these, the last lesson had those. You just have to be careful, notice whether you're looking for y prime or y double prime. And so let's give that a whirl here. You might want to pause the video and try it and then come back. All right, so first of all, I'm going to find the derivative because I need that. So if I find y prime here, that's going to be equal to negative 2e to the negative 2x. And I'm going to plug that in here in place of y prime. So now I have 3 times negative 2e to the negative 2x plus 5 times our original y, which is e to the negative 2x, equals negative e to the negative 2x. That's what I'm trying to verify. All right, so we're going to do some simplifying. This would be negative 6e to the negative 2x plus 5e to the negative 2x. And you probably can already see that, yes, that is in fact equal to negative e to the, oh, that should have been a negative 2x. There we go. To the negative 2x, right? So it is a solution. All right, let's continue with the presentation. We're going to be looking at slope fields. If you have your notes handy, you'll see that slope fields are a direction field. They just tell us what the general slope looks like for a given differential equation. Kind of handy, helps you figure out maybe what does the original function look like. And so we just go along, and in this case, they give us these dots, and that's where they want you to draw the slope. One thing I always like to look for is there a place where the slope is 0? Because those are easy to draw. Is there a place where the slope is undefined? And if I look here, I will get a slope of 0 whenever x is 0. So if x is 0, then dy dx is 0. So all the places where x equals 0, I'm going to have 0 slope. And remember, to show a 0 slope, we just draw a little horizontal line. So every one of these dots where x is 0, I'll have a horizontal line. Places where it's undefined, if y equals 0, then dy dx is undefined. Let's say is undefined. All right, so y equals 0. So all along here, this is undefined. I'm not going to fill in any of those dots along that line. All right, normally they wouldn't even have dots. You just leave it blank. Now we need to go along. We have a remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points to fill in our remaining slopes. So let's start here. This is the point negative 2, 2. If I put in negative 2 here, I'll get a 2 divided by 2 is 1. So I just want to make a slope that looks like it's a slope of 1. All right, here we have negative 1, 2. That'd be 1 over 2. It'd be slope of a half, so it should be flatter than that last one. And that's really, and you don't get points taken off if your slope isn't exact. It should just show steeper slopes are steeper little chunks like this. All right, this one we have the point 1, 2, so that would be negative 1/2. So it should look like this one, but going the opposite direction. If I do 2, 2, that's negative 2 over 2, which would be a slope of negative 1. So my slope should be going in the negative direction. This is the point negative 2, 1, which would turn that into a positive 2 over 1. So my slope should be steeper than this one. This is negative 1, 1, which would be 1 over 1, slope of 1. Should hopefully match this one here. This is the point 1, 1, which would be a slope of negative 1. This is the 0.21, a slope of -2. Got to make it steeper than that one. All right, remember, we're not putting anything in here. -2, -1 would be a slope of -2. -1, -1, slope of -1. 1, -1 would be a slope of -1, -1, so a +1. And here we have 2, -1, which would be -2 over -1, a slope of 2. Okay, and a lot of times there's symmetry, like you can sort of see in this graph. All right, let's look at the next example. This time it's asking us, below is shown a slope field for which differential equation? So this one I can't do any factoring. I might want to factor out a y in this case, just to give me maybe a little better idea of maybe where the slope is 0. That's sometimes helpful. I'm going to factor out an x in this one, y plus 1. And this is x plus 1 cubed. Can't do anything with that. All right, so let's look here. Looks like we have a slope of 0 when y is 0. All right, so let's see here. Well, we have a slope of 0 if y is 0. Yes. Slope of 0 if y is 0. Yes. Slope of 0 if y is 0. Yes. So far, slope of 0 if y is 0. Nope, so we can rule off this one. Slope of 0 if y is 0. Nope, there's no y in there. All right, so now we're down to these three. Let's see what else we know. This looks like at -1, when x is -1, our slope is 0. X -1, our slope is 0. Nope. All right, we're down to these two. X -1, slope 0. Nope. So our answer in this case is C. It's the only one that meets those criteria. So one thing I always look for, I look for these values where the slopes are 0, slopes are 0. If you can't get anything from that, then try just trying in some other points. Sometimes these 0 slopes are hidden in other places that you're going to want to check out. All right, this time I'm going to move my picture here. I can't see the problem. This time it says, consider the differential equation dy dx equals 1/3 x times y minus 2 squared. Sketch solution curves that pass through 0, 2, and 1, 0. So we're going to do exactly what it's asking us to do. So our first point is point 0, 2. You see it's marked on the graph. When you're drawing these solution curves, you go through the given point and you just follow the slope. So in this case, it looks like my slope here through 0, 2 would just be a slope of 0. On the AP exam, you just want to draw these as best you can. Don't put arrows on the end. Make sure you go through the point. Follow the curve as best you can. My other one was 1, 0. So it looks like my curve maybe is going here. And you just do your best to follow along at the whatever the slope is doing at that given point. Looks like we're kind of coming here. Follow along. Probably going like that. All right, and that's what you do. Don't make it any more of a big deal. Again, stay within the slope field. Don't put arrows on the end. All right, which could be a differential equation for this given slope field. Now this time it's a little different. Instead of giving us the derivative, this time they give us the function. So let's figure what a little graph like this. Notice we're only in the first quadrant. So if it's x squared in the first quadrant, this would be going like this, like a U shape. If I look, is that going to be what those slopes are doing? Nope. E to the x, again, e to the x also curves upwards. It would just be up 1, right, on the y-axis. So again, it's curving up. That doesn't look like what's happening here. E to the -x would just be curving downward through the 0.01. So it's not that. Cosine x, most of you probably know. That would be doing something like this and then coming back up. Doesn't look like it's doing that. So now we're left with the natural log of x. And yes, in quadrant 1, the natural log of x graph does in fact look like this slope, this direction like that. So my answer choice is E. All right, that's all we have. Your assignment today is in 2 parts. You have homework number 25 at AP Classroom, and there's also a Slope Fields free response question practice worksheet I'd like you to try, and the link for that's on Schoology. So if you have any questions, just send me an email. So good luck.